Good evening. I'm Austin, and we'll be talking about hemostasis, mainly about the four mechanisms of hemostasis. I didn't quite understand hemostasis or how exactly bruises form and heal. I just knew once you got a bruise, it was just blood coming towards the superficial region of the epidermis. Hemostasis is the prevention or arrest of blood loss. The four mechanisms we'll be talking about today would be the vascular constriction, primary hemostasis, the formation of platelet plug, secondary hemostasis, which is blood coagulation, and then the dissolution of the blood clot or the fibrinolytic system. Vascular constriction is a smooth muscle when the smooth muscle contracts to reduce the blood flow of the injured vessel. For example, this is our injured vessel, and if our smooth muscle contracts after an injury, blood will slow down and can't flow as smooth as this. It doesn't just keep flowing and pumping through. And contracts happen from our local myogenic spasm, which is like local muscle spasms, our endothelium, the epithelium is contracting and helping it. And then our nervous reflexes, because our nerves are connected to everything in our body some type of way. And then our thromboxane, A2 come from platelets, which is going to be known as the TA2. Second in the mechanism would be the formation of the platelet plug, also known as the primary hemostasis. So platelets are formed to form clots, and they come from megakaryocytes, which is a form of white blood cell, and those come from bone marrow. So GP1B, also known as our glycoprotein, are adhesions to damaged areas. So, for example, we'll say these are our glycoproteins, and they're forming at the bottom of our injured vessel. And platelets will come and form in the form of flat. They'll come as a disc, come and form, and as they get towards the glycoprotein, they come into a spiked ball to take up more surface area, so it's easier to fill up and stop and form coagulation. And then our granule release is activated by our thrombin and ADP. While ADP stimulates further granule release and activation, thrombin activates our fibrinogen, turning them into fibrin. Our recruitment and aggregation of thrombin stabilizes the plug by promoting more platelet contraction, so more platelets are coming and becoming more compact. Our secondary hemostasis, it happens faster. There's extrinsic and intrinsic pathway, which is part of our coagulation cascade, and we'll get to that. Our secondary hemostasis, our coagulation portion, happens 15 to 20 seconds in severe trauma. While getting to a coagulant cascade, the intrinsic is 1 to 6 minutes, while extrinsic is less than 15 seconds, coming in fast. The tissue factor is the most important in secondary to initiate our coagulation. And thrombin, like I explained earlier, activates it. Once it's activated, turns fibrinogen into fibrin. As we see Captain America right here, fibrin holds both vessel walls together so the vessel is not getting ripped apart even more. And fibrin becomes a mesh net, we want to say, that traps platelet, mesh net vessel, traps platelet and red blood cells in because they help form, stick together, and doesn't let anything leak out. Because without fibrin, everything just falls slowly. And then last would be our fibrinolytic system, or the dissolution of the blood clot, which takes away the blood clot. Plasminogen and thrombin, or just plasminogen, is stuck in the clot. And over several days, the tissue will release a plasminogen activator, also known as TPA. And once plasminogen is activated to plasmin. Plasmin eats away at the fibrin fibers and other clotting factors, which leaves the vessel a little bit open, but able to flow through and close up towards the end, removing the clot. So if you have a bruise, the bruise will go away in no time due to our plasmin eating away the fibrin, so the color is not sitting out there or our vessel just stuck. Thank you.